Hello 6th graders, welcome to Big Ideas Math, 7th grade Math, section 5.6, direct variation lesson. Pause while you write section 5.6, direct variation lesson in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is students will use a formal definition of direct variation. Pause to copy the following key idea into your math notebook. You should copy the definitions into the Words Worth Knowing section of your interactive student notebook. Two quantities, x and y, show direct variation when y equals kx, where k is a number and k does not equal 0. So k is going to be a coefficient as long as k does not equal 0. The number k is called the constant of proportionality. The graph of y equals kx is a line with a slope of k that passes through the origin. So two quantities that show direct variation are in a proportional relationship. Today we'll start at example 1, which appears on page 200 of your red textbook, identifying direct variation. Tell whether x and y show direct variation. Explain your reasoning. Example A. So we see in example A we have some points, x and y, and it says plot the points and draw a line through the points. So our textbook has done that for us. And we have our graph right here. And it says the line does not pass through the origin, so x and y do not show direct variation. And letter B says the same thing, and you can see that we have that the line does pass through the origin. Remember that the origin is 0, 0. And since the line passes through the origin, x and y do show direct variation. Formula. Let's take a look at example number 2. We're still identifying direct variation. Our directions are tell whether x and y show direct variation and to explain our reasoning. Letter A is y plus 1 equals 2x, so we solve for y. So we want y to fit into this kind of a format with y equal to a coefficient and x. It can't do that because we can't combine the 2x and the minus 1. So x and y do not show direct variation. If we look at letter B, we have 1/2 y equals x. When we solve for y, we get y equals 2x because we multiply both sides times 1/2 to solve for y. And so it can be written as y equals a coefficient times x. So x and y do show direct variation. So let's take a look at the on your own problems, and I want you to be writing these in your notebooks. So it says tell whether x and y show direct variation and explain your reasoning. So we can look at number 1 and we see that since 0 is not paired up with 0, so we've got x and y, 0 is paired up with -2. So that's not going to pass through the origin. So it doesn't pass through the origin, so it does not show direct variation. So no and does not pass through the origin would be our answer. And number 2, we're going to draw a quick little graph of that up at the top. So you can see by my graph, even though it's not perfect, that if you graph points 1, 4, and 2, 8, that when you draw the line, it would pass through the origin. So our answer here would be yes, and that it does pass through the origin. So now let's look at number 3, and we're going to do the same thing. We are going to draw a graph. And here, the graph does pass through the origin, however, it isn't a straight line. So the answer is no, because it's not a straight line. So let's look at numbers 4, 5, and 6, where you are not given points to graph, you are given just an equation. So we're going to take a look at solving for y. So we want to get y by itself, and we do that by, in number 4, we're going to divide both sides by x. So xy divided by x and 3 divided by x. So when you solve this, it comes out to y equals 3 divided by x. And so we can't fit that into the formula of y equals kx. So the answer is no. So let's look at number 5. We're going to divide both sides by 1/3. So x divided by 1/3 is the same as x times 3. So it's 3x equals y. So that does look like y equals a number, which is k times x. We just have our things on opposite sides, but that's okay. So that answer is yes. And finally, we're going to look at number 6. Y plus 1 equals x. We're going to get y by itself by subtracting 1 from both sides. So we have y equals x minus 1. So we can't get that minus 1 to be a coefficient, so the answer is no. Now we're going to look at the real-life application. It says the table shows the area y in square feet that a robotic vacuum cleans in x minutes. And we are going to graph the data, so that's been done for us, thank goodness. Tell whether x and y are directly proportional, so whether it's a direct variation. Graph the data, draw a line through the points. So the graph is a line through the origin, so it's a straight line and it goes through the origin, so x and y are directly proportional. And it says write an equation that represents the line. So we do that by choosing any 2 points to find the slope of the line. So they chose, I'm not sure which 2 points they chose, but we can take any 2, and so I'm going to pick some nice easy ones, like the first 2 that I put a box around there, and we take the y, so we would take 16 minus 8 and 1 minus 1/2, and that equals 8 over 1/2. And that equals 8 divided by 1/2, which equals, which is the same as 8 times 2, which equals 16. So we got the same thing that the book got. So the slope of the line is the constant of proportionality, so that is k. So that is the coefficient that sits in front of the x. So an equation for the line is y equals 16x. So we're going to use the equation to find the area cleaned in 10 minutes. So we write the equation, y equals 16x, so y equals 16 times 10, because we're cleaning for 10 minutes, and we multiply, so 16 times 10 equals 160, so the vacuum cleans 160 square feet in 10 minutes. So let's look at the on your own question. What if the battery weakens and the robot begins cleaning less and less area each minute? Do x and y show direct variation? Well, since the battery would be weakening and the rate of change would not necessarily be constant, the answer would be no. No, the rate of change is not constant. In order to finish this lesson, you need to be prepared with your notes, vocabulary, and other work from the flipped lesson completed, and any questions you have for your teacher, and have a good attitude.